All right, let's continue our discussion of dynamics and look at some forces. First off, when we're summing forces, we have to understand that forces are often described as a push or a pull. Forces are vectors. This means they have magnitude and direction. And forces can be added just as vectors are added. If I have two forces in the same direction, I can add their magnitude. If I have forces in opposite directions, I can subtract their magnitude. Here's how we notate the sum of all forces. Notice the Greek symbol means sum of all, and we can just add force 1 plus force 2 plus force 3 all the way to force 10, 20, whatever, however many forces we're looking at. The Greek capital letter sigma is used to indicate the sum of all. That's what it means. If forces are balanced, then the sum of all forces is 0, and no change in the motion will occur. So here you go, you have the sum of all forces is 0. You could also see it as the sum of forces in the x direction and the sum of forces in the y direction are 0. So if the sum of all forces is 0, then these two things are also true. When you have unbalanced forces, this will change an object's state of motion. There may be two or more, or maybe even more than that, forces that could be unbalanced. To find the sum of an unbalanced set of forces, you add the force vectors acting upon the object. Usually this involves finding and adding the vector components. So if you had a force of 2 newtons in the 0 degree and 2 newtons in the 90 degree, then you could find whatever the resultant force is if you add those unbalanced forces. And so we can call this equilibrium force, which is a force that balances one or more other concurrent forces. Concurrent forces just means that it goes through the same point. So two or more forces that are going through the same point of motion. A vector has the same magnitude as the vector sum of the other unbalanced forces, but pointing in the opposite direction. So if I have two forces that are acting in a 90 degree, then I would attach a third equilibrium force in the opposite direction and balance them out. So the force equilibrium is going to be equal to the negative sum of all forces in the opposite directions. If the sum of all forces on an object is 0, then any unknown force must be the equilibrium of all the known forces. Now let's talk a little bit about weight. This is the force of gravity acting on an object. It's also a vector pointing straight downward. It is often notated as the force of W, the force of weight. So let's talk about some types of forces. All forces are classified. They're either fundamental or mechanical. There are 4 fundamental forces. Those are gravitational force, which is proportional to the masses of interacting objects. So the gravity of Earth pulling on you is proportionate to its size. If you were to go to the moon, the gravity of the moon pulling on you is proportionate to its size. It can exert its influence over theoretically infinite distances. We do not know how far you must be away from the Earth in order to not have gravity of the Earth exerted on you. All objects will exert gravitational force on all other objects. Another fundamental force is the electromagnetic force. This is used to explain magnetism and electricity. Notice electromagnetic. It's a long-range force, and there's also a short-range force of it. The third fundamental force is strong nuclear interaction force. And then the fourth one is weak nuclear interaction force. So let's classify our forces. Non-contact forces would be like gravity, electromagnetic forces, and sometimes these are also called action at a distance. There does not need to be any contact in order for it to be acting upon an object. Field theory also attempts to explain these non-contact forces, basically meaning that for any object there is a field of influence. Virtual particles have also been offered as an explanation. Then you have contact forces. So we talked about non-contact. Now we're looking at contact forces. This means there has to be contact involved. Transmitted only by physical contact between objects, and they include the following. Tensile force is pulling things apart. Compressive, pushing things together or crushing them. Torsion is twist. And also friction, opposite motion between two objects in contact. Finally, we have shear. This is where it causes layers within matter to slide past one another. When we measure forces, we use some of the following instruments. We use a spring scale to measure in newtons. We can use a load cell. We can also use a pressure gauge. We can use a ballistic pendulum. We can use an accelerometer. We can use a force table.